Hey guys, welcome to day 33 of Codeforces Everyday until GM. Sorry for the short video yesterday. We should have back to normal schedule, longer videos, like 1 hour long. I'm gonna try to make this one at least 1 hour long today, but yeah, can't promise it'll be too much longer than that because I'm honestly dying to play some Overwatch right now. I don't know what's with me. Maybe it's the new update hype or whatever that's going on. It's not even out yet, but like they released a new character and she looks cool as fuck. So right after I make this video, I'm gonna go play. Yeah, but okay. Without further ado, let's jump straight into it. Let's see if we can do 3 problems today. These problems are getting harder. Like these 1200 rated ones, they take me about an hour. So um, maybe not, but we'll do our best. Supposedly, I've heard from sources that the A2OJ ladder is actually a bit outdated. Like, all of these problems are like harder for. They were like 1200 rated back then. Like, people are saying that like 1600 rated back then are like 1200 now, and questions have just in general gotten a lot harder. And I know that's true for like most competitive programming sources. Like, problems have just gotten harder over time, but I don't know. For now, I'll just like stick to the ladder until I find something better. Like, the ladder is cool. I'm not gonna lie. I really like the idea where it like tracks your progress as you go. That was like my biggest complaint about the last one. I had to manually type in everything, but yeah, we might try CS51 if um it's like if it's just super outdated, but like I don't think doing problems will ever hurt, you know. So we might just stick to the ladder. But okay. Without further ado, let's jump straight into it. Okay. Shushens in sequence. Sequence of in written on a blackboard. The Shushens can perform one operation on it, with the operation consisting of 2 steps. Find the number that goes kth in the current sequence and add the same number at the end of the sequence. Delete the first number of the current sequence. Shushens wonders how many operations all the numbers on the board will be the same, whether all numbers will be the same. The first line contains int and k equals map int input split. Second line contains a equals list map int input split, and then print the number of operations required. Okay, impossible to print -1. So basically, find the number that goes in the kth current sequence and add it to the end. Delete the first number in the current sequence. How many operations will all the numbers on the board be the same? And whether the numbers will ever be the same. Okay, so this question is gonna be like some sort of pattern, like I have to see a pattern type question. And the first test case after the first operation sequence is, so k is 2, so it's 1, remove 3, 1, 1, 1, so it's 1 operation. This one, 3, put 3 at the end, remove 3. Put 1 at the end, remove 1. Okay. So never. Okay. I see what's going on. So basically, I think the pattern is something like let me pull up Excalidraw. If it's like A, B, 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 if K is so these have to be the same number. If K is ever like in this group, then it's possible, but if it's in this group, it's impossible, because then you'll be A, B, 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 A, and then B, 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 A, A. Is this right? If it's... You pop the first and you move K to the end. So you want to find a substring of characters where they're all the same, and you want to make sure K is in that substring. Okay, wait, what if I have like A, B, C scenario? I'm here, and then it's B, C, C, and then C, C, C. That works. But then what if it's A, B, C, D, and we're here? B, C, D, C, and we're on D. C, D, C, D, we're on C. D, C, D, C, we're on D. Okay, this is impossible. Letters after make it not work, right? A, B, C, D, C, and we're here becomes B, C, D, C, C, and B, and then C, D, C, C, D, and then C, D, C, C, D, C, 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 D, C, D, and then it's... Am I fucking this up? Wait, hold on. A, B, C, D, C, B, C, D, C, 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 D. So we're looking at D here. C, D, C, C, D, D, C, C, D, C, and then C, C, D, C, 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 or C, D, C, C, D, D, C, C, D, C, 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 D, C, C, and we're looping. So basically, we're looking at the substring at the end. If K is in the if K is in the last substring, if it's possible. Else it's impossible. What if there's a case where it's like A, B, and we're here? Let's remove, okay, let's do like simply A, B, and we're here. A, B, A, B, A, B, A, B, A. It's impossible, right? If it's just A, B, and we're here, it's B, A, and then A, B, B, A. That's impossible. A, B, and we're here. A, B, A, B, A, B, A, B. A, A, B, A, A, B, A, A, B, A, B, and we're repeating. So, okay, so yeah, you just check the last substring and see if K is in that last substring. So you split A into K to the end, and then you iterate through and check if all of them are the same number. Python check if all elements and lists are the same. Do I just have to iterate? I guess we can use a set, right? So, okay, so I think that's the answer. Okay, so A equals A, K to the end, print A. Let's just make sure everything's working here. And we're including the right values. 1, so that's not right. 1, 2. So K minus 1 to the end. There we go. Now, A equals set. A equals len set A. And equals 1. So I'm pretty sure this can check, like, if the length of set A is equals 1, then A is now a bool. So let's not name this A. Let's name this let's name this substring. Subster is same. Is all same. And then if subster is all same, then we okay, so this is a thing. What we're basically doing right now is checking if it's true. Let me just do like pass, and then else print -1. We're basically checking if it's possible, not how many orientations. So if I run this should work. Not how many operations required. Basically, the operations required would just be. Let me look at A, B, B, B again. A, B, 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 and we're here. A, B, 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 A, or A, B, 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 B. Okay, well, basically, it's enough to squeeze out the non-AKs in front of the list. So we need to count where K starts. Like, because if our arrow was here, then we're only checking here, right? Where technically it's all the way back here, and we only need 2 operations. but over here would be saying it's 4 operations. So this is just checking if it's true. We need to find the first index of k. Value k is equal to ak, and then index k equals value k dot index, or it's a dot index value k. Well, I could just do this and not have this, and just do index. And then with this, so this will give us 0, 1, 2. This will give us 2. And do we just print index? -1. Okay, so we're not getting subs that are all the same. Why? Substr is 1, 1. False. Oh, because we gotta do length substring here. There we go. 1, 1. Wait, let me try with like a case where it's 1. Okay, so n and k, we need 1, 2, 3. N is 1, 2, 5, 3, and then 1, 1, 2, 2, 2, something like this. And expected is 2. Okay. Let's see if this works. Runtime error. That's not what I expected to see here. 1, 1, 1. They didn't give me a jury answer. Index out of range. Index AK. Let's do AK -1. Is 0. I guess that works. Let's try this. Wrong answer, test 22. So at least we're getting there. Like, there's probably just some special edge case. My output is 0, which is just not true. The case is this and this. Okay. Okay. So K is 11. Check 1, 2, 3. 0. So we check 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We find 1. And then we're finding the first index of 1. So that doesn't work. We need to find the first index of 1 in the substring. So how can we do this? Mm, start from the back. I mean, we can just iterate, I guess. If I did a dot index and then like a subarray, how does that work? Python index of a subarray in an array. I can't just use index of, I guess. I actually have to iterate. I could flip it, then count how many times same digit. I don't even need to flip it, I can just increment backwards. And then subtract that from it. So if all same We're gonna do for I in range start from in stop at -1 start stop step -1, and then we can have an index variable, set that equal to, okay, sub r len equals 0. Value equals a -1. If AI is not equal value, break, else sub r len plus equals 1, and print sub r len, print in minus sub r len, because n would be 20, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'd have 10 values. So then we would get 10. And we wouldn't need this. Okay, index out of bounds, AI. Why? We're starting at n equals 20, so start at n minus 1. There we go. There we go, we got it. How long did that take? 27 minutes. Okay, that's good. Kill all these. And then reload. Boom. Sienna and divisors. 1200. Mathematician, sequence of n is divisible by 3 positive integers. Consisting of n possible integers, n is divisible by 3. Each of them is at most 7. Wants to split the sequence into groups so that each group, A, B, C, A divides B, B divides C, naturally wants each element of the sequence to belong to exactly one group of 3. Thus, if the required partition exists, then it has n divided by 3 groups of 3. Help Sienna find the required partition, or else say that it doesn't exist. The first line contains n equals int input. Okay. The next line contains n positive integers. Each element is 7. It's guaranteed that n is divisible by 3. Output, if the required partition exists, print and divide by 3, groups of 3. If there's no values in increasing order, separate the groups and integers in the groups by white space. If there's multiple solutions, you can print any of them. Okay, so But what are we trying to do? A A divides B, B divides C, B, C. Okay, I see. This is impossible because we fail case 1. So it looks like we use a counter. And then say we had a 3. If we had a prime number, we're cooked. Oh, so they're at most 7. A divides B, B divides C. Okay, so they can't be the same number, so needs to be at least 3 different numbers. Okay, so what I'm drawing from this is there needs to be in order for it to not be -1, we need at least 3 different numbers, no odds, except 1. And if it's 3 different numbers, 2, 4, or 1, 2, 6 works. 1, 2, 4 works. 2, 4, 6 doesn't work. 6 is the greatest number. At most 7. Maximum of 7. 7 doesn't work though. So it'd be 6. What would work? 6, 2, 1 would work. 6, 4 wouldn't work. So you basically always want 2, 1. You greedily want 2, 1, and then if you have a 6 or a 4, it doesn't matter. And if you have an odd, you're cooked. You're printing -1. So, okay, so then these are our default cases. If these don't hold true, we just print out -1, and then we continue. So let's just add these. If oh, I need a counter, right? Python check. Wonder if there's a way I don't need counter. Check num of diff. I feel like counter is just the easiest way. Oh, len set. Never mind. I can just do len set like I did earlier. If len set a is less than 3, so meaning 2 numbers or 1 number, then print -1, exit. If five or 3 in A or 5 in A or 7 in A print -1 exit. Now, wait, so this case should work now. And then, now we greedily choose. So how does the partition exist? Here wants to split as a sequence of n positive integers where n is divisible by 3. 7 isn't divisible by 3. Well, okay. It doesn't matter. Each element of the sequence will belong to exactly one group of 3. If the partition exists, then it has n divided by 3 groups of 3. So 2 groups. Maximum of 2 groups, minimum of 0 groups. Okay, it's at least 3, so minimum of 1 group. Wait. No. N can be 999. Oh, I misunderstood. Okay. So now it basically just depends on the number of 1s and 2s. The answer, okay, so it's I do think we need to count all the different numbers. So we count, and then we basically end up with 1 number of 1s, 2 number of 2s, and then 4, 6. This is too big. Okay. Right. And then we greedy. Multiple solutions, you can print any of them. Print in increasing order. So we can greedily combine like these. So it's always 1, 2. Well, every time we do a combine, we -1, and then -1. And then if 1 or 2 or 4 and 6 equals 0, then we exit. Basically. So from collections import counter a equals counter a. Let's just print out a to check what it looks like. Okay, that's right. And then while A1 is greater than is greater than 0 and A2 is greater than 0 and A4 plus A6 is greater than 0. Print 1, 2, if A4 is greater than 0, for A else if okay, we're gonna do this either way, so let's bring this out so we don't have duplicates. I brought the wrong ones out. Bring 1 and 2 out. Bring out here. L if A6 is greater than 0, we print 6, and then A6 minus equals 1, else we just exit. Yeah. Wrong answer. Okay, I really struggled to do these first try, and it's kind of pissing me off. Like, I'm just not seeing a case. I'll put in -1 for this, but I expect 136. Why? Oh, okay. Because 3 and 6 work. That's why. Okay, I missed that case. 361. So if 5 and 7, okay, like this. And then so we want to greedily choose 6 and 3. Okay, there is at least 3 numbers what if we have... Okay, so we still have the counter. We want to greedily choose 6 and 3s now. 6, 3, 1s. Okay, so... let's do while true, and then we'll figure it out. Print 1, 3, 6. Our cases are print 1, 3, 6, 1, 2, 6, and then 1, 2, 4. These are the 3 different things that we can print out. We greedily choose this first, then we choose this, then we try this. So this is A1 minus equals 1, A3. Okay. Two, 4. And then this is if 1 still exists, 3 exists, and 6 exists. So if 1 still exists, like if 1, A1 is greater than 0, like this, else exit. And then if we run out of 6s but then have leftover 3s, we're fucked. So we print -1. So this is so we can track a 2 print. Was this instead of just printing this straight up, we can append like this, and then else -1. And then if we're out of 6s, if A6 is less than it, if A6 is greater than 0, then we can do these two. Okay, this is very complicated. And I feel like there's just an easier way to code this. But okay, let's just make it work first and then we'll figure it out. So if 1 exists and if 6 exists, this case is if 3 exists. If they don't exist, then we just print -1. So if 1 through 6 exists, okay, well we can probably just do like an if statement for each of these. Like maybe we can do it like this. And this is while A1 greater than 0 and A3 greater than 0 and A6 greater than 0. We do this. 1, 2, 2, 4. And then we at the end we check if len2 print is equal to is not equal to n divided by 3 print -1, else for I in print to print star I. This didn't work. Well, it did work because it's in the order. I want a case where it's alright, whatever. Let's just try it. The only thing that would break. Okay, wrong answer, test 13. There's one case that I'm thinking of, but I just can't visualize it. Let's see. It's my output's this, Jerry's output is -1. So one, where am I getting an extra 2 from? counter is, we have 2 2s, yes. Then in the first case, so we have 1 6 0 3s, so nothing happens through this one. In this one, though, we have 1 6. Oh, 1 2 4 also. No, we calculate that. We have 1 6. So we lose 1 2. And we lose 1 1. Okay, that looks right. 3 equals negative 2. How do we get this? This is supposed to be 2. Okay, let's fix it. Oh, we print out negative 1 now. Okay, just typo. Logic seems to have been correct. Yes, okay. Logic was correct. We just typed in the wrong number. Got it. Nice. Took another 25 minutes, I would say. So this is 1,200? These 1,200 questions are taking me around like 25, 30 minutes, which is good pacing. They're all like B's. Oh, these are A's. That's not good. If they're A's for like a div what? Contest. Div 2? A's for a div 2 contest taking me 30 minutes. That means div 2... 2B is probably like 1,300. I could probably only do 2 problems on div 2 right now. I kind of want to check what I can do for... Like, I've done a div 2, right? Have I? This one, div 3, div 4, div 3. Okay, maybe not. I've done Hello 2026. Which, I don't know what div Hello 2026 is, though. Let me Google. What div is Hello 26 Codeforces? Div 1, div 2-ish. I've done... Okay, when I was doing the contest, I could only do A. I tried B and C and failed it. B was yet another mechs problem, right? Yeah, and C was war strategy. B... How hard was yet another mechs problem? It wasn't that difficult. I think I would be able to do yet another mechs problem now, to be honest. Oh, they put the rating in for this finally. 1,100. Problem set. Yeah, okay. Let me go in and put the rating for these. Yet another. War strategy is 1,500. War strategy was a formula problem. It didn't. I don't know if it's 1,500. I think maybe it's like 1,400. 1,400. Because as long as you get the formula and you understand it, it's not hard at all. And it's like, it feels like one piece. It's like, you handle the left, you handle the right, like the same. And then you have this one formula that you use for both. Cyclic merging felt like 3 pieces. And it's only 1,300. So, like, cyclic merging felt much harder than war strategy to me. So I don't know if this is properly rated, but yet another max problem. 1,100 is understandable. This question, I don't know. The ratings feel so weird. There's definitely something off about them. Okay, and I need to go back and put in binary array game being 800 rated. This is a hard 800 rated. Because this is one of those questions where if you see the pattern or not, right? And it took me it took me quite a while, like 30 minutes to see the pattern. I would say this is like a 900 rated problem. If I were to do it today, yeah, I don't know. Anyway, this video is dragging. We've done 2 problems. I accidentally just closed out of this one on accident, and as per usual, I need to use the restroom, so I might just end the video here. I wanted to do one more, but I don't want to go through the BS of using the restroom and then coming back. It's always annoying to do. But yeah, I guess if y'all enjoyed this video, be sure to like and subscribe, and I'll see y'all guys tomorrow. I'm gonna go play some Overwatch after, and then I have a board game night with friends, which is cool. So yeah, I'll see y'all guys later. I'll do more problems tomorrow. Bye.